from Kana Kingdom Smart Education. Today I am going to teach you mathematics of 3rd class and the topic is numbers up to 1000. Today we are going to learn in this chapter is about 4 digits number, place value and face value, number on abacus, successor and predecessor, comparing numbers. Now we are going to learn about 4-digit number. The smallest 3-digit number is 999. On adding 1 to 999, we get smallest 4-digit number, that is 1000. On adding 1 to 999, we get the smallest 4-digit number, that is 1000. According to their place value, the digits are placed from right to left, that is ones place, tens place, 100 place, and the last one is 1000 place. Now we are going to learn reading 4-digit number. First we read the digit at the 1000 place. We read the digit at the 1000 place at first, and then the digit at the 100 place, and then the digit at the 100 place. Tens and ones digits are read together. Tens and ones digits are read together. Now we are going to learn how to read 4-digit number through this 10 example. Okay, the number 1 is 1087. The number 1087 will be read as 1087. The number 1087 will be read as 1087. The number 3097, the second number 3097 will be read as 3097. The number 3097 will be read as 3097. And the third number, the number 7654. The number 7654 will be read as 7654. The number 7654 will be read as 7654. And the fourth example is the number 5623 will be read as 5623. The number 5623 will be read as 5623. And the fifth example is the number 5432. The number 5432 will be read as 5432. The number 5432 will be read as 5432. The sixth example is the number 2754. The number 2754 will be read as 2754. The number 2754 will be read as 2754. And the seventh example is 6542. The number 6542 will be read as 6542. The number 6542 will be read as 6542. The eighth example is the number 3428. The number 3428 will be read as the number 3428 will be read as 3428. The number 3428 will be read as 3428. And the ninth example is 5069. The number 5069 will be read as 5069. The number 5069 will be read as 5069. And the 10th example or the last example is the number 6890. 6890. The number 6890 will be read as 6890. The number 6890 will be read as 6890. The number 6890 will be read as 6890. Now we are going to learn about place value and face value. Place value. The place value of a digit in a number is the digit multiplied by its position. The place value of a digit in a number is the digit multiplied by its position in a place value chart. For example, in the number 7689, to find the place value of each digit in this number, first we have to make a chart, that is place value chart. That in the same way that I have made the place value chart in the screen. See, I have put this number in a place value chart. The number 7689. The place value of 9 in the number 7689 is 9 ones, because 9 is in the ones place. And the place value of 8 in the number 7689 is 8 tens, because it is in the place of tens. And the place value of a 6 in the number 7689 is 600, because 6 is in the position or place of 100. The place value of 7 in the number 7689 is 7000, because 7 is in the place of 1000 in a place value chart. Now we are going to see one example of place value chart. Place value chart in the number 6802. To find out the place value, first we have to make a place value chart in the same way that I had made in a screen. See, look at the screen, dear student. See, and put the numbers in the place value chart. The place value of 2 in a number 6802 is 2, because 2 is in the place of ones, right? So 2 ones is a place value of 2 in the number 6802. The second, the place value of 0 is 0, because the place value of 0 is always 0 wherever it is located or wherever it is placed in a place value chart. The third one is 8. The place value of 8 in the number 6802 is 800, because it is in the place of 100. And the place value of 6 in the number 6802 is 6000 because it is in the place of 6000 in a place value chart. Now we are going to learn about face value. The face value of a digit in a number is the digit itself. The face value of a digit in a number is the digit itself, irrespective of the position of a digit in a number. It means the face value of a digit in a number is the digit itself. The position of a number does not matter in a face value. For example, in the number 6785, in the number 6785, the face value of 6 is 6, the face value of 7 is 7, the face value of 8 is 8, and the face value of 5 is 5. It means the position of a digit does not matter in a face value. The face value of a digit in a number is a digit itself. In second example, in the number 9087, in the number 9087, the face value of 9 is 9, the face value of 9 is 9, and the face value of 0 is 0, the face value of 8 is 8, the face value of 7 is 7, because the face value of a digit in a number is a digit itself. The position of a digit, wherever it is placed in a place value chart, does not matter. Now we are going to see one video clip of place value and face value.
Hello friends, I am Miss Honey. Would you like to learn about the place value and face value of a digit in a number today? Yeah, so let's begin. First, let me tell you what we mean by the place value of a digit. Place value is the value of the digit according to its position in the number, such as ones, tens, hundreds, etc. Let us understand this with the help of a number. Let us take the number 346. We write the number 346 in the place value chart as number 3 in the hundreds column, number 4 in the tens column, and number 6 in the ones column. Now let us look at the place value of each digit. As the number 3 is in the hundreds column, it means that there are 3 hundreds, and so its place value is 3 into 100, that is 300. As the number 4 is in the tens column, it means that there are 4 tens, and so its place value is 4 into 10, that is 40. As the number 6 is in the ones column, it means that there are 6 ones, and so its place value is 6 into 1, that is 6. Now let's try to solve one more example. Number 605. Let us place each number in its respective column. So, number 6 goes in the hundreds column, number 0 in tens column, and number 5 in the ones column. The place value of number 6 is 6 into 100, that is 600. The place value of number 0 is 0, as there are 0 tens. The place value of number 5 is 5 into 1, that is 5. Now, let us learn what the face value of a digit is. The face value of each digit in a number is same as the digit itself. Let us look at the number 346 again to understand this. As you know already, number 3 is placed in the hundreds column, number 4 in the tens column, and number 6 in the ones column. But the face value of a digit is the same as the digit itself, irrespective of where it comes in the place value chart. So, the face value of digit 3 is 3 only. The face value of digit 4 is 4 only. And the face value of digit 6 is 6. Now, let us solve one more example. Look at the number 890. Here, the face value of digit 8 is 8. The face value of digit 9 is 9. The face value of digit 0 is 0. Wow! Wasn't it easy to understand the place value and face value of a digit?
Now we are going to learn about numbers in abacus. Number in abacus. Abacus is a simple device used for calculation. Abacus is a simple device which is used for calculation. Abacus itself does not calculate. Abacus itself does not calculate, but it has human beings to calculate. It has human beings to calculate. Dear student, please look at the picture of abacus on the screen. See, it's the abacus. It's a picture of abacus. Okay. Tell me how many bits are there in thousand place? 2, right? And how many bits are there in hundred place? 4, right? Okay. How many bits are there in tens place? 1. And how many bits are there in ones place? 3. It means it is representing the number 2413. It is represent this picture represent the number 2413. Now we'll see one example of how number can be represented on abacus. Let us take one example or one number 4057. To show this number on an abacus, we will place different color beads on the rods, which is representing thousand, hundred, tens and ones. First, we will place 4 beads on a 1000 rods. We will place 4 beads on a 1000 rod. And second, we will not place any beads on the 100 place, because in 100 place there is 0. So in third, that means we will place 5 beads on the tens rod, because in tens we have 5 in the number 4057. Okay, at last we will place 7 beads on a ones rod, because we have 7 in the number 4057. So we will place 7 beads on a ones rod. So see the picture of the abacus. It representing the number 4057. Now we will see one video clip of how number can be representing on abacus.
Hello students, I welcome you all to this classroom. Today's topic is 4-digit numbers on the abacus. You know what is an abacus? An abacus is a simple device used for calculations. An abacus itself doesn't calculate, but it helps human beings to calculate. This is an abacus. In abacus, each bit represents counting units and each rod represents places, that is, ones place, tens place, hundreds place, and thousands place. Let's understand this better through an example. Look at here. Here we have an abacus, and these are the places: ones place, tens place, hundreds place, and thousands place. Look at the ones place. How many bits are there at ones place? 1, 2, 3, 4, 5. So we have 5 bits. So write 5 below ones place. Now go to the next rod. In the next rod we have how many bits? 1, 2, 3 and 4. So write 4 below tens place. Now go to the next place, that is hundreds place. In hundreds place we have 1, 2 bits. So write 2 below hundreds place. Now go to the next place, that is thousand. In thousands place, how many bits are there? 1, 2, 3. 3 bits are there. So write 3 below thousands place. Now what is the number? Now we got the number, that is 3245. Let's write this numeral in standard form. So the standard form of this numeral is 3245. Let's find the place values. You know what is place value? Okay, place value of a digit is the digit multiply the place where the digit is. For example, look at here. 3 is at thousands place. So the place value of 3 will be 3 multiply 1000. Now go to the next place, that is hundreds place. Which digit is there at hundreds place? 2. So the place value of 2 is 2 multiply 100. Now go to the next place. Next place is tens place. Who is the tens place? 4. So the place value of 4 is 4 multiply 10. Now go to the next digit. The next digit is 5. 5 is at which place? 1's place. So the place value of 5 is 5 multiply 1. After multiplying, what will be the product? So let's see. 3 multiply 1000 equals to 3000. 2 multiply 100 equals to 200. 4 multiply 10 equals to 40. 5 multiply 1 equals to 5. Let's write this in expanded form. Now we will write the expanded form of the numeral 3245. So expanded form is nothing but the sum of all the place values. So let's write. So the expanded form of 3245 is 3000 plus 200 plus 40 plus 5. So this is the expanded form of this number 3245. Now let's write the word form of this number 3245. The word form is 3 is a 1000 form, thousands place, so we will write 3245. Let's go to another example. See, here we have another abacus having places, ones place, tens place, hundreds place and thousands place. How many bits are there at ones place? 1, 2. 2 bits are there. So I will write 2 below ones place. How many bits are there in tens place? No bits. So we will write 0. How many bits are there at hundreds place? Only 1 bit is there. So I will write 1 below 100. How many bits are there at thousands place? 1, 2, 3 and 4. So I will write 4 below thousands place. So the numeral is 4102. So let's write the standard form of this numeral. So the standard form of this numeral, that is 4102. Let's find the place values. As we have already studied, the place value is of a digit is the digit multiply the place where the digit is. So 4 is a 1000 place. So the place value of 4 is 4 multiply 1000. Place value of 1 is 1 multiply 100, because 1 is that hundredth place. So the place value of 0 is 0 multiply tens, that is 10. 0 multiply 10, because 0 is at tens place. Now the next digit is 2. 2 is at which place? Ones place. So 2 multiply 1. Now let's find the product. So 4 multiply 1000 is 4000. 1 multiply 100 is 100. 0 multiply 10 is 0. When you will multiply 0 by any number, the product is always 0. 2 multiply 1 is 2. Let's write the expanded form of this numeral. So expanded form, as we have studied, nothing but the sum of all place values. So expanded form will be 4000 plus 100 plus 0 plus 2. Now we will write the word form of this numeral. The word form of this numeral will be 4 is at thousands place, so 4102. I hope the concept is clear to you all.
Successor and predecessor. Successor. Successor means the number that comes just after a given number is called successor. Successor means the number that comes just after a given number is called successor. For example, the successor of 6 is 7 because 7 comes just after 6. The successor of 6789 is 6790 because 6790 comes just after 6789. And the third one is the successor of 5241 is 5242 because 5242 comes just after 5241. And the successor of 4284 is 4285 because 4285 comes just after 4284. The successor of 4912 is 4913 because the number 4913 comes just after the number 4912. Okay. The successor of 5219 is 5220 because the number 5220 comes just after the number 5219. And the successor of 6529 is 6530 because the number 6530 comes just after the number 6529. Now we are going to see one video clip of successor and predecessor. Now we are going to learn about predecessor. The number that comes just before a given number is called its predecessor. The number that comes just before a given number is called its predecessor. For example, the predecessor of 9 is 8. For example, the predecessor of 9 is 8 because 8 comes just before 9. And the predecessor of 9876 is 9875. The predecessor of 9876 is 9875. In the same way, the predecessor of 5643 is 5642. In the same way, the predecessor of 4561 is 4560. In the same way, the predecessor of 2159 is 2158. The predecessor of 2159 is 2158. In the same way, the predecessor of 3600 the predecessor of 3650 is 3649. In the same way, the predecessor of 2691 is 2690. In the same way, the predecessor of 8596 is 8595. In the same way, the predecessor of 1596 is 1595. The predecessor of 1596 is 1595.
Successor. What is successor and how to find successor of a number? The number that comes just after a number is called its successor. Let us look at it in detail. To find find successor of any given number, if the number is n, then the successor of the number n is n plus 1. You have to add 1 to the given number to find its successor. Let me give you some examples. What is successor of 8? Successor of 8 equal to 8 plus 1 equal to 9. Let us see another example of successor. What is successor of 99? Successor of 99 equal to 99 plus 1, that is 100. Predecessor. What is predecessor? The number that comes before a number is called its predecessor. Let me tell you how to find predecessor of a number with some examples. If a number is n, then the predecessor of number n is n minus 1. To find predecessor of any given number, you have to subtract 1 from the given number. Let me give you some examples. What is predecessor of number 8? Predecessor of number 8 equal to 8 minus 1, that is number 7. Let us see another example of predecessor. What is predecessor of 100? Predecessor of 100 equal to 100 minus 1 equal to 99. So, how to write the predecessor and successor of the given numbers? It is so simple. To find the successor of a number, add 1 to that number. If the number is n, then the successor of the number n is n plus 1. To find predecessor of a number, subtract 1 from that number. So, predecessor of number n equal to n minus 1. Let us observe an interesting pattern in successor and predecessor concept. Take any two consecutive numbers, 1 and 2 or 8 and 9, etc. Here in this example, I have taken 8 and 9. Successor of 8 equal to 8 plus 1, which is 9. And predecessor of 9 is 9 minus 1, which is 8. 9 is the successor of 8 and 8 is the predecessor of 9. So, what you have observed? If the number n is the successor of number m, then number m is the predecessor of number n. Let me give you another example. Here, I have taken two consecutive numbers, 99 and 100. Successor of 99 is 99 plus 1, which is 100. Predecessor of 100 is 100 minus 1, which is 99. So, 100 is successor of 99 and 99 is the predecessor of 100. So, this is how you can find predecessor and successor of any given number.
Now we are going to learn about comparing numbers. In maths, to compare means to examine the difference between numbers, quantities or values to decide if it is greater than, smaller than or equals to another quantity or number. In maths, to compare means to examine the difference between two numbers, quantities or values to decide if it is greater than, smaller than or equals to another quantity or number. When we compare the number with 4 digits, we look at the thousand place first. We look at the thousand place first. If these two digits are same, if the two digits are same, then compare the digits in hundred place and so on. When we compare the number with four digit, we look at the thousand place first. If these two digits are same, then compare the digit in the thousand place and so on. Okay, now we are going to see some example of comparing number. Okay, or to see how to compare one number with another. Okay, question number 1 or example 1, compare 7,891 and 5,302. First, look at the thousand place in the both number. Okay, then 7,000 is obviously 7 is greater than 5, so 7,891 is greater than 5,302. Okay, 7,891 is greater than 5,302. Okay, see question number 2. Compare 4,625 and 4,681. Here both numbers 4,625 and 4,681 have the same number of digits in 1000 place and in 100 place, right? While comparing the number 4,625 with 4,681, the digits in 1000 place are the same. Again, the digits in 100 place are also same. In the tens place, it is greater than 2. So the number 4,681 is greater than 4,625. Okay, now see question number 3. Compare 7,598 and 7,599. Here both number 7,599 and 7,598 have the same number of digits. While comparing in thousand place, the digits in both number are same. Again, comparing in 100 place, the digits in both number are same. Again, while comparing in tens place, the number have same digits in tens place also. So at last, while comparing in ones place, the 9 is greater than 8. So 7,599 is greater than 7,598.
Let's learn in this lesson how to compare and order numbers. Alright, so compare the following numbers: 4,026, 2,940 and 4,377. Then part A, arrange them in order beginning with the smallest, and part B, arrange them in order beginning with the greatest. Alright, so how do we do that? How do we compare numbers? Well, as always, first of all, we bring our place value chart and we put the three numbers in the chart. Okay, so the first number is 4,026. So 4 in the thousands place, nothing or 0 in the hundreds place, 2 in the tens place, and 6 in the ones place. Similarly, we put 2,940 and the last number 4,377. Now let's compare. We know that we must start comparing the thousands first. Okay, now for the thousands, we have, for the first number we have 4, the second number we have 2, and the third number again we have 4. Now 2 is obviously smaller than 4, so 2000s is smaller than 4000s. So from here we can tell straight away that the number in the middle row, which is 2940, is the smallest of all. So there you go. Let's label it first, meaning it's the smallest. Now we only need to compare the top two numbers, the numbers that begin with 4000 in each. Okay, so the first number is 4026 and the second number is 4377, and we only need to compare those two numbers now, okay, to find out which one is the next smaller number. Alright, now since both of them have 4, the digit 4 in the thousands place, we obviously cannot make a comparison here, so we go to comparing the digits in the hundreds place. Now the digit in the hundreds place for the first number is 0, while the digit in the hundreds place for the second number is 3. Now obviously 0 hundreds is smaller than 3 hundreds, so we know now that the first number, or the top number, which is 4026, is smaller than 4377. So there you go, the second smaller number of the three is 4026. Then obviously the one that's left, the last number, which is 4377, is the biggest of the three numbers. So let's arrange them in order then, beginning with the smallest. Well, the smallest is 2940. Then comes the second smallest, which is 4026, and the third one, which is the biggest of all, the greatest of all, and that's 4377. So that's how we arrange them from the smallest to the greatest. Now how about part B, arranging them beginning with the greatest? Well, we simply flip the order. So 4377 comes first, next is 4026, and then last is 2940. So we just reverse the order. Alright, and that gives us the answer to part B. And that also brings us to the end of this